All right. Good afternoon, everyone, and thanks for coming to Westinghouse Women in Nuclear's events for Science Week. Today, we're going to talk about engineering disciplines. We are recording this meeting, so you should see a message showing that we're recording. Just be aware of your surroundings if you're going to be on camera. If you don't want to be recorded, you can obscure your background or turn off your camera. And if you don't want to be audio recorded, you can always mute your microphone and put your questions in the Q&A or the chat. We are going to be using a Q&A function today, and we'll be monitoring that. So if you have questions, go ahead and put them in the Q&A or in the chat, and we will do our best to address all the questions that come up. So my name is Sylena Smith. I'm here with my colleagues Adana Stanish, Kellyanne Zayan, and Hayley Wagreich. And today we are going to talk about engineering disciplines. Before we get started any further, if you are viewing as a group, we would love if you would put in the chat how many people are watching with you. Without further ado, I'll get started. All right. So I might be a little biased since I'm an engineer, but I definitely think engineering is a great career. And our goal today is to explain how you can best prepare yourself to be an engineer, what different kind of disciplines there are, and things you can do right now in high school to help yourself out. The national starting pay for engineers in the United States is about $77,000 a year, which is great. And there are many schools nearby that actually have top tier, top ranked engineering programs. Penn State's one of them. Carnegie Mellon is one of them. Ohio State, Michigan, Purdue. So these are schools that are relatively close by that have very high ranked engineering programs. You'll have diverse different kind of engineering and science programs at most universities. And we really you're highly encouraged when you're in engineering in college to do internships, starting usually in your sophomore year. And the cool thing about engineering internships is they're almost always paid. And you might notice that in other majors, there are a lot of unpaid internships. Engineering internships are most always paid. You can go on, Adana. So I am going to start out talking about nuclear engineering. I am a nuclear engineer. Nuclear engineering is really kind of broad. It's not just nuclear weapons or nuclear power. There's actually medicine, reactors, space applications, you name it in engineering. So if you want to go to the next slide, we'll talk about that some more. So a nuclear engineer is going to be basically fundamentally harnessing that potential energy inside of an atom to give the humans benefit. So there are industrial and medical applications to it. So you could be working on nuclear reactors that generate power, not just for large cities, like large nuclear reactors. We also have small reactors that will power. Maybe you have an outpost in Alaska or something like that, and you need just a small amount of power. There are small reactors for that. The Navy has a whole fleet of submarines that run on nuclear power since the 1960s, actually. And we even have space applications. There are satellites and that have been running since the 70s, actually, that run on nuclear power. You could be using it, helping develop fusion energy, which is a newer technology. And then you could also be working in nuclear medicine. So we have not just X-rays or detecting or detecting illnesses, things for detecting illnesses. We also have nuclear treatments with radioisotopes that can actually target and kill cancer cells. And then you could also be contributing to national security by helping upkeep the stockpile of nuclear weapons. I'll go to the next slide. Now, mechanical engineering, I actually had to take a few mechanical engineering classes while I was in college. It's kind of considered the Jack and Jill of all trades. And there are a lot of fundamental classes that you might have to take, even if you're in, say, civil engineering or chemical. There are some mechanical engineering classes that you might have to take. So we could talk about those on the next slide. So like I said, mechanical engineering is going to have very broad, wide-ranging applications. You can think about just about anything has a mechanical process to it. For instance, the chair that I'm sitting in, or the chair that you're sitting in, has to be able to withstand the weight of a person sitting on the chair, the weight of that person moving around or joking around with friends or leaning back. All those things, a mechanical engineer is going to help make sure that that chair can withstand all those forces. And it's the same thing no matter if it's an aircraft carrier or a toy or a TV stand, a car. Those are all these wide-ranging applications that this is applicable to. So you might even be doing cutting-edge things like working on medical devices, along with the nuclear engineer that we were talking about earlier. So like I said, mechanical engineers are often referred to as the Jack and Jill of all trades, and you'll be working in nearly every area of technology, almost anywhere you want to, which is the cool thing about mechanical engineering and engineering in general. So do we want to move to the next?
Yeah, so biomedical engineering is kind of where your engineering meets medicine. So you can think about, like Sylena talked about with medical devices and nuclear isotopes, you can be working, the biomedical engineer would work with maybe the mechanical engineer on the design of the prosthetic. And their focus would really be how that prosthetic is going to interact with the human body and how it could mimic the human body. And if you were working on radioisotopes as a biomedical engineer, you would work with the nuclear engineers and they would figure out how those isotopes are emitting energy. And then the biomedical engineer would really figure out how that energy is interacting with the human body, where those isotopes should be put, how you want to place them, how to place them, the type of device that can place them. So it's a really cool field to be in if you really want to work with medicine and engineering. You can work on almost anything. I think the next slide has some examples. So you can work on imaging devices like x-rays, ultrasounds, EKGs. You can work on like contacts, anything that's going to contact the human body. So like your contact lenses, your glasses. You could think about, you might have a biomedical engineer even working on like sports apparel, moisture wicking apparel. You could work in tech. Think about your like antimicrobial screen cases. So those are things that might have input from a biomedical engineer. So the kind of main premise is that you're applying these engineering principles that you learn to the healthcare industry, and you really want to focus on improving the quality of life for people. Computer engineering is the next one. So I like to think about computer engineering as kind of the interface between the human side of technology, the computer side of technology, and the mechanical side of technology. So how am I interacting with my computer? How is the software making the computer run? How is the software making the hardware run? That's kind of the types of things you can think about in computer engineering. So if we go to the next slide, you would think about like developing software. In almost any industry, you're going to need computer engineers, but this would be really focused on looking at the software side of things. So looking at if you're in, again, the medical industry has a lot of opportunities. If you don't like looking at people, you can look at the software used to run the machines, like the MRIs and the X-rays. You can work on like modeling different types of diseases. That's a cool one. In the aerospace industry, it says talking about like air traffic control, animations and movies. So there's a lot of things you can do with computer engineering. So this is really like how people interact with software and the computers. And civil engineering is probably one that you've heard of before. It's really about the structures you see around you. So a civil engineer might work on figuring out how the bridge works. And I like to think about it as like how your structures are going to interact with themselves, the environment over a long period of time. So as a civil engineer, you could be really involved in the building process of the bridge, or you could be involved in inspecting the bridge and understanding how it's standing up to the water currents and the wind and the cars driving over it and all of those things over its lifetime. So you can go to the next slide, please. Yeah, so this is talking about maybe schools that withstand an earthquake. So if you're on a fault zone, you might need to consider that more than you would here in Pittsburgh, versus here we have to think about the snow and the rain and how your concrete is expanding and contracting as the ground freezes. You can work on things like highways, skyscrapers, bridges, water reservoirs. We work at Westinghouse in the nuclear, so we have civil engineers who work on the infrastructure that houses the nuclear plant. So you can also work in a lot of different industries. If you want to go into medical, maybe you can work on hospitals and figure out the best place to put the hospital. So there's a lot of things you can do with civil engineering too. I think we'll go to the next one.
All right, well, that's my turn. Thank you. My name's Kellyanne. Thanks everyone for joining. I will also work for Westinghouse, but I'm actually down in Columbia, South Carolina at their fuel fabrication facility. So we actually make the fuel that goes in reactors here. So moving into the next discipline here, environmental engineering, you obviously see a lot of stuff with, pictures of the earth on here. We've got some water, some different aspects of the environment. So this is really how does an engineer take the products that we're working on, that companies are making, and ensure that we're serving the environment, we're protecting the environment, and we're doing everything we need to ensure that environment sustainability is there. So if you could go to the next slide, please. Typically, people who go into environmental engineering, they care very much about pollution, protecting natural resources, saving the environment, and actually being able to do something about some of the issues that we have. It's no secret that we have to do more recycling. We have a lot of waste and plastics as the number of humans in the world grows. We have all these products that have to go somewhere. So environmental engineers really work to clean up oceans, rivers, drinking water, make sure that we have air pollution control for our equipment, and then designing more of those effective recycling systems, or how to dispose of toxic waste and protect the environment while still accomplishing the tasks that they need to. So that's environmental engineering. If you could go to the next slide, please. This is chemical engineering, which I really want to talk about. I'm a chemical engineer. So I went to a small school in Michigan Tech, and studied a lot of different chemical processes, specifically oil and gas. And somehow I find myself down here in the nuclear field. Next slide, please. So I worked for a chemical company in Detroit and then moved down to Columbia here. I worked on our chemical process at the facility. And it really is what this first bullet says. You're taking what you learned in chemistry class and you're using it to create products on a large scale. Sometimes it's a small scale, but for the most part, engineers have taken this stuff and scaled it up to big production quantities. There's a lot of different chemical processes out there that do innovative and different creative things to turn one product into another. Just think of sort of like baking a cake, if you will. That's an oven. That's what they call a unit operations process. reactors, not just a nuclear reactor, but anytime you mix two chemicals and you get a reaction, anything like that. So this has applications in just about every industry as well, which is hopefully what you're getting from this presentation is engineering is everywhere. Pharmaceutical companies, food manufacturing companies, here nuclear fuel, any sort of chemicals, anything in the automotive industry. It really is an exciting engineering field. And obviously my favorite because I got a chemical engineering degree and I absolutely love chemistry. So next slide, please. The next one I'm going to talk about, and I think the final one for me, is electrical engineering, which really has taken off since the internet, and I would say not just since electricity's here, but internet and everything you do. Think of every device that you use or has electricity. You're touching it all day, every day. So of course, naturally, an electrical engineer is going to have applications all around the world. So we see a light bulb, a power pole here, a microchip. Next slide, please. This is really an in-demand field. My brother's an electrical engineer. You can develop components for cell phones, cameras, roller coasters, as well as communication systems, more medical devices, testing. We talk about it on a macro or micro scale, macro being large scale. Think about power grids across the country where you have different nuclear power plants feeding into that, or coal plants or steam plants, as well as micro, which is like the really small stuff, your microchips in your car, telling an airbag to go off, telling the radio to turn on, helping you with cruise control, all convenient, nice, great things to have brought to you by electrical engineering. Of course, this also has applications in robotics, computer networks, wireless stuff, you name it. So there's just so many opportunities here in electrical as well. So thanks.
Hi, everyone. My name's Adana Stanish. I'm also like Kellyanne. I'm a chemical engineer, but my time here at Westinghouse, I've been groomed as a mechanical engineer and interface with basically everyone that we've already talked to, and hopefully a little bit more today. So today I wanted to talk through industrial engineering. And this is kind of very similar to mechanical engineering, kind of where do you want to go and you can kind of make it. But industrial engineering is really looking at the process. How can we be more efficient? How can we do things a little bit better? So for example, if you're very, very organized or like to organize things or reorganize things over time, this might be an area that you want to look into a little bit more. It's really looking at kind of a big picture of engineering or a process or people, and really finding a good way to work more efficiently, operate safer. So really, if you think about it, over the past summer, if you were at an amusement park waiting in line to get on the next roller coaster, there was an industrial engineer in the background thinking of how can we get people moving through the line faster, or how can we get people to, maybe we need to put a drink station halfway through because it's really, really long. How can we, maybe there's phone adapters because we know people are going to be waiting here for a very long time, or whatever that might be. An industrial engineer is looking to see how can we better make it better for people and make it better for the process. So it's just something to kind of think about of that overarching aspect of engineering. Another area is aerospace engineering. So I think first and foremost, it comes to, airplanes, aircraft, kind of your initial thoughts of where an aerospace engineer could be or work. But it doesn't have to stop there. I actually work with a number of aerospace engineers, and interestingly enough, there's nuclear applications that maybe, like we've mentioned before, we put satellites into space. Maybe they're looking at different ways to put reactors in space, but also on the turbo machinery that we use in power plants, not just nuclear, but coal plants and things like that, where they're trying to increase electric electricity, they're going to put turbo machinery in there, and they need to understand the aerodynamics of their system. How can they be more efficient? How can they make sure that we can transport? Maybe it's, working on race cars to design the aspect and working with your mechanical engineers on the next automotive car design. Maybe you're working for the Navy on working on vessel design and things like that to be more aerodynamic within the water so you can have better jet propulsion. So really, it's one of those areas that I know it's been a common theme today, that there's so many options, but really each one is really what you want to make of it. So just kind of keep those in mind, that if you have a strong area, it might not be the first option that you think of where you end up applying that engineering degree. And similarly, petroleum engineering. So this, I tend to think, is a little bit more of a very specific field that you could get into. But this is really pulling on the heartstrings of your chemical engineers that might say, I have a really good solid foundation of where I want to go. I want to work in the gas and oil industry. And so really it's building upon those same methods, those same engineering skills of understanding the process, but applying it for something very specific. So we'll see that here in throughout the industry of our natural gas. How can we get oil from the different areas and up to the gas stations or uses throughout the industry? It's really looking at how can we make those processes, where do we drill, where do we put production operations, where could we refine the production operations, become more efficient, and really making sure that we're getting what we want out of the core and into what we need to use for day in, day out. So I hope this is really helpful. And I think I'll turn it over back to Sylena to kind of give us a quick summary of where we were today, and then we can open it up for questions.
All right. So I hope one of the things that you've gotten out of this is how engineering has a lot of broad applications. And one thing I like to make sure that I communicate is that, say you graduate or study engineering and you go to work in the workplace, and then you discover that I don't want to be an engineer. I want to manage people, or I want to, work in communications. Having an engineering background really gives you, in some ways, a leg up or a special skill. Because say you do go into communications instead of engineering, then you can be the person that communicates to the public the things that the engineers are working on in a way that the public can really digest. So just because you go into engineering doesn't mean that you're stuck in engineering. Engineering is really kind of like a tool that opens the door, the key that opens the door to a whole world of possibilities of what you can do. So if you're curious about things, you have a questioning attitude, like how does this work? Or maybe you want to improve people's lives or solve problems, engineering is a great career to go into. There are a lot of different technical disciplines within engineering, even more than what we talked about here. So I encourage you to research the different schools that you're interested in, see what kind of engineering programs they have, because I think you'll find that there are even some, like for instance, material science and engineering is another field that we didn't talk about today. And then noting that while you're doing this, data shows that the salary for engineering is higher than the average worker in the United States. We'll go to the next slide. So we didn't want to leave here without giving you some idea of what to do next if you think you want to study engineering. There are some things you can do in high school that can accelerate your path and make it a little bit easier for you to get through an engineering program, and also save you money, so which is always nice. So I would encourage everyone, you want to take challenging courses, algebra, calculus, statistics, chemistry, physics. Take all of those classes in high school that you can. not only is that going to set you up on a good foundation when you get to engineering and you start taking those classes, but it's going to save you money if you've taken, well, the physics you take in college isn't the same as high school. You'll still have to take it. But you'll at least have that good foundation for some of those subjects that you'll be studying. Try to job shadow an engineer. We've had students shadow here. Maybe there's a firm that's nearer to your school that you could call them up and see if you can job shadow an engineer there. Definitely join extracurricular activities, sports and clubs. These you might not think that they have a direct aspect to engineering, but they show the college that you know how to be a team player, that you know how to work with other people, and that being in these extracurricular activities shows them that you are involved in your community. And that's important for the colleges because it shows you're a well-rounded student. I love volunteering. I volunteer all the time. I'm volunteering right now to give you this presentation. And so I think volunteering, just like being in extracurriculars, can really, you got to utilize that stuff and put it in your college applications that you volunteered with an organization that you're passionate about. If you can find a STEM camp, definitely join a STEM camp because it's extracurricular, but it also shows you're really interested in STEM. STEM being science, technology, engineering, and math, just in case. I worked when I was in high school, and so on my applications, I put some of my work history. They didn't ask, oh, what jobs have you held? But I talked about them in my essays. So definitely leverage that experience because it all counts. And then I like to put on here, tutor your peers, because when you tutor other people, it increases your understanding of the subjects that you're studying. And the colleges, you'll know that, and the colleges know that too. And then to really save yourself money, if they are available, take advanced placement courses. So these AP courses, as long as you score at a certain level, you can take credit for some of those AP classes in the college of your choice. And that would reduce the number of classes that you have to take at the college and incidentally saving you money. So I think that is it for the formal presentation part of this webinar. And so I definitely open it up for you all to ask questions. We'll leave the chat open for the entire meeting. So if you have a question, go ahead and put it in the chat or in the Q&A and we will get to it. So while we're waiting for any questions to come through, could maybe we talk about which college you went to and what you liked about it? Adana, or maybe Kellyanne, you want to go first?
Sure. So, like I said, I live in Columbia, South Carolina now, but I'm from Michigan and I went to Michigan Technological University, which is a small but very competitively ranked engineering school in northern Michigan. So a little bit of a hike from the Pittsburgh area. It is a small school, but it is primarily an engineering school. When I was in school, I did 3 summer internships and I actually worked for General Motors. At that time, which is very popular to do automotive when you live in and around Michigan. And I really realized through those internships, I was at 3 different locations, across the couple years I worked there. I just didn't love automotive. And so there's an advantage to doing an internship and realizing, hey, you know what? This is not really what I want to do, but I still gained experience and I made good money as an intern doing it. And it, in fact, helped me pay for part of my college tuition. So that's my story. And it looks like we have a student question popping up in the chat here. So please go right ahead.
Let's see if I can enable audio for everyone, or at least for them. Oh, if things on my screen weren't getting in the way.
While we're waiting for that to pop up, I'll just add my I come from a family of engineers, and it was really easy for me to pick engineering, but I specifically chose chemical because I really liked chemistry, and I knew I wanted to pick a job that would pay me. You know, you gotta work to live. That is the reality. And so might as well do something you're passionate about and make good money too. The question is, what did I do at GM during my internship? So I had 3 separate ones. My first, so there's not really a lot of chemical engineering within automotive. In my experience, it's more geared toward environmental engineering or perhaps paint. So I ended up working with the environmental group. My first summer, I was running around the facility that I worked at in Flint. I was updating old drawings. I was doing some gas stack off gas calculations and really just getting the lay of the land. I mean, you got to think, you know, I was 19 years old. So I had some really great mentors that year or that summer, and that was very helpful. I also worked at a foundry down in Ohio, just south of Toledo, and that's where I did the bulk of like the environmental stuff, and that was more making sure the plant met the environmental program expectations, that we had our reports on cycle, the regulators have certain requirements, all these things that when you get into the business world, companies have expectations from the EPA or whatever local entities of the, you know, waste stuff that they're supposed to be dealing with. Pollution prevention plans, clean water plans, all that kind of stuff.
I guess I can talk a little bit about where I went. So when I didn't start college until I was 21. I was working up to that time, and I finally decided that I'm going to go to college because I don't want to work with people. I just want to work with computers or something. So I started out at a community college, Columbus State Community College, which was super beneficial because they had a transfer program specifically to allow students to study their first couple of years there and then transfer to a 4-year college. And so I got the 2-year degree, associate's degree, and then I went to the Ohio State University and studied chemical engineering. And I actually got a scholarship because I had an associate's degree, which was really cool. So doing the associate's degree saved me a lot of money because I didn't have any loans during community college. And then when I went to college, they gave me money. So that was really nice. I studied chemical engineering because I loved chemistry and math. And my last year of community college, I did a project that got me interested in fusion. And then I decided I wanted to do nuclear engineering. So Ohio State doesn't have an undergrad nuclear. So then I went to graduate school at Ohio State for nuclear engineering. So I definitely encourage everyone to do community college if you, especially because a lot of times they're closer to your house and you don't have the housing costs as well. We have another one. How long does a typical engineer go to college and what is the cost? Oh, well, my undergrad took me 5 years. How long did yours take, Kellyanne?
Mine was 4 years, and that's actually not typical for where I went to school. Most people do 5 years. And the reason being is I did internships every summer, and I didn't delay my coursework for that. But a lot of the people I went to school with would take an extra semester and do a long, what they call co-op, which is like an opportunity to work for a longer duration of time during your school year. And then that extended their college. Again, you're getting paid a lot during that time, and they have programs set up for you to do that. So I would say for most people, it's 4 to 5 years.
Yeah,
As far as oh, I'm sorry, go ahead.
I was going to add, I also did 5 years. And in that time, I was able to take just 2 or 3 extra classes over that additional year and came out with 2 additional minors. So it's just something to think about, that you might have another passion and maybe you don't have another 4 years in it for yourself. But you could pick up some additional minors. So I majored in chemical engineering. I got a minor in chemistry and environmental engineering. So I was very close to getting a nuclear engineering minor as well. So those are just things to kind of think about that added flavors while you're there. But Kellyanne, I think you wanted to address the cost aspect, right?
Yeah, so I was, were offering a program when I was graduating to stay for another year and get a master's degree in chemical engineering. And when I say I thought about it, but I was so done with school. I was so ready to start working and make money. The cost of it really depends on the school you go to. So, and if you're out of state or in state, Michigan Tech and a lot of the other schools in Michigan, I would say a lot of the tuition costs are probably about $100,000 for a 4-year program. Now, I went to Michigan Tech. I got a scholarship that took care of 60% of that. So my student loans when I graduated was $40,000. And that sounds insurmountable, but it is not, because again, I knocked that off by working, paying those loans down when I was in school. And then when I graduated, I lived at home. I was on what I jokingly called the friends and family plan for my living situation. There are ways that you can focus on that debt and get out of it. But the biggest thing is that when you pick a degree program where you're going to make a good salary, you have the opportunity to pay those student loans back. Student loans are not a bad thing if you have a plan to move forward and get out of them. Now, what Sylena did with the community college, she talked about some of her costs were a lot lower up front, and then she finished and she got a scholarship. So there are ways around that too.
You also want to pay attention to like a private institution versus a public institution.
Yes.
That will also make a big difference. I'm in my really early career, so I'm fresh out of it and dealing with all of the jumps and hurdles of being an adult and having to pay my loans back and all of those fun things. My car broke, so now I need to buy a car. So just like all those fun little expenses. And like Kellyanne said, having the loan debt, it seems scary, but it's not the worst thing in the world. I have some debt as well. I went to a private school. Understanding, like having that really serious conversation with your parents, if they are planning on paying anything or if they're not, having that conversation and understanding what financial wellness looks like for you and your family is really important. And also, if you have a chance, a lot of schools require like a personal finance class. I took it in high school and I didn't learn that much, but I took it again in college and it was like the best class I've ever taken. I highly recommend that every single person take a personal finance class and like actually pay attention. Don't just do it because it's like something you feel like you need to do, but setting yourself up for that success is really important. It's a big number and it's a scary number, especially when you're in school, you're not necessarily working. I worked through school part-time, but it can be really overwhelming to also work through school. So it's scary, but just having a really serious conversation, understanding your earning potential is a lot higher than some of your peers. Looking for scholarships, your schools a lot of times will, if you're a competitive candidate for that school, they will offer you a scholarship. Like Kellyanne had, I also had one, like from the beginning, and that's a really good way. And I think also like Sylena had, that's a good way to understand how much you're paying from the beginning versus sometimes some of the smaller scholarships that you apply for, they might change on a year-to-year basis. So yeah, and a lot of those like scholarships you get right off the bat are based on your academics and continuing all the academics, like holding yourself to a good standard. So there are ways that you can pay for it, and it's not too bad when you get out, I promise.
I was going to add that yesterday I was looking around at some of the highest ranked colleges, which is why I was able to rattle off a list of Big Ten colleges. But I saw, so if you compare, I think MIT was in the 45,000 and up per tuition range. Ohio State, of course, I looked at them because that's where I went, and it was under 12,000. But this is for in-state. Carnegie Mellon was around 29,000 tuition a year, and so was Penn State. And Pitt was actually pretty affordable in the 11 to 12,000 range too. Those all sound like big numbers, but I mean, I didn't have any, I did do the community college the first 2 years, but I took out loans my last 3 years, and I did not take all of the loans that they offered me. I only took what I needed. I did not work my junior year because everyone said the junior year is the hardest one. So I did take out a little bit more for that one. But for the most part, I rejected the loans that I didn't need. And I worked through college when it fit. And I ended up paying off my loans before the 10-year. I paid them off faster than what's required. There's like a 10-year plan, and I ended up paying them off before the 10 years. So we have another question. Did you all do STEM-based electives in high school? And is it important to your college career to get that experience? How about Dana?
So I did not. So I'll be the example of, I probably had the minimalist electives going into college. So I had a pretty boring application. But I think so it's okay. It's okay that you don't have a perfect application, is my point. But the electives that I did take, I found passion in them at that time. So find something in school that makes you happy. I had a number of friends that joined the marching band because they love playing music and attending the Friday night football team games. I also had friends that were in the drama club or the plays and things like that. So find the piece that fits for you. I would do softball. That was my thing. I like to play softball. I didn't play softball for the high school team, but I played for a recreational. And so I think you finding what you're passionate about and exemplifying that in your applications is what makes you unique. So just because someone else is doing it doesn't mean you have to, but figure out what you want to illustrate as why you're being different. I'm an example that you don't have to do all of that. But what I will say is that college presented the opportunity to get outside of my comfort zone. And that's really where I learned time management. There was no parent there telling me what I needed to do or when to eat or when to study. So being that your own advocate is a very hard lesson to learn. So I would start trying to do that now, less and less leaning on parents and teachers and really trying to facilitate that aspect. But also college presented a lot of opportunities. I started off at a branch campus at Penn State McKeesport. I think it's now called Greater Allegheny. But then after 2 years, I went to University Park at Penn State. So it kind of bridged a very large college and made it seem a lot smaller because I already had friends from the branch campuses, and it really made a good transition. But being at a branch campus, I could join sports and kind of getting outside of my comfort zone. So I played on the volleyball teams and traveled around the community colleges and even other branch campuses. I played fast pitch softball. I joined different clubs. So it's an opportunity to kind of see what you want to do, try new things. And I think playing sports and going to college at the same time was a really good tool to figure out that time management, because there were times when I had 5 or 6 classes, like 21 credits, which they tell you never to do, and I was playing sports. So I had no time but to focus on studying when I needed to, go to practice and go to my classes. So it's just something to think about, that maybe college is the avenue where you try something new.
I'll say I didn't do really any STEM-based electives in high school either. I was in band. I loved band. I played all 4 years. I was the first seat drummer for 2 years. I did theater, which I also loved. And I played soccer year round. So we did outdoor soccer in the fall and then indoor soccer in the summer or spring. And so even though I didn't do STEM electives, those are things that still show that you're a real well-rounded human, in my opinion. So.
And I guess I think the team here wanted to just identify that today is not the only discussion. If you guys have more questions, I think all four of us would be willing to take those. We could, you guys could send emails to us if you have any questions, if you wanted to job shadow any of us, or just talk through a day and what we do every day. I think that offer is always on the table. So I just wanted to make sure that you guys heard that. And so if a question comes after today's session, feel free to reach out to any one of us and we'll find a coworker or colleague that might be able to be the perfect fit as well. So just something to think about.
I'm putting my email in the chat just in case if somebody has an interest and they wanted to, or a follow-up question for that. Good looking out. Hey, Dana. Another question, how does the college that you select affect your job opportunities? Oh, that's a good question. Who would like to take that one?
I'll take a stab at it. I will say, being from Michigan, especially in the Metro Detroit area, a lot of the students that I went to high school with primarily went to Big Ten schools, Michigan State, University of Michigan, the Ohio State, a few others. I did not choose to go to one of those schools. I went to a much, much smaller school that still has a really good ranking, but I would say what's more important is that you pick a program that is ABET accredited. That's what they call it. That's something that employers are looking for, that accreditation. And it's nothing that you have to do. It's what the university has done to say, hey, we do have a good program and here's our credentials for that. Another thing that I considered, I was looking at a private engineering school in Flint that was like 30 minutes from my parents' house, a little bit too close to home for me. But they did not have a chemical engineering program, or they had stopped it for a number of years and were restarting. So I was looking at two schools, one that had a very well-established chemical engineering program, one that did not. And I realized what's more important here is to go to a school that has a well-established program that's known for that program and had a really great lab and allowed me the opportunity to get involved and make those sort of experiences there, or have those experiences there. So it's, now I live in South Carolina, I work for Westinghouse. Nobody here knows what Michigan Tech is. They actually usually assume that it's some sort of like 2-year technical college, because that's what we have down here when we call them Midlands Tech or Carolina Tech. That's what it is. It's that ABET accreditation that you care about. And then even if you're unsure of what engineering discipline you want to study, you still want to see that they have accredited programs. And then you have to ask yourself as a student, I thought about going to University of Michigan. I thought it'd be super fun to be in the big house and go to football games. And frankly, when I went to apply, I had to write an essay and I was like, I don't want to do that. I'm an engineering student, not a writing student. So I didn't even apply, but I also know that I probably would have been lost on such a large campus. At such a large school, I would have been just a number. So again, I picked a small school so that I could have, more interaction with teachers and a smaller knit group of students to be with. So I think that's important. Gosh, I thought of one more thing. I'm sorry, I'm hogging the chat here. I think what's also very important is that you push yourself to get an internship immediately. That is, you cannot get to senior year and not have any work experience. That's critical. And that can be very uncomfortable because you're 18 years old, you're fresh in college, you just started your program and boom, it's career fair in the fall. But that is, pushing yourself to get work experience is what employers are looking for by the time you graduate.
So
that's all I'll say. I'll turn it over to someone else.
Kellyanne is really awesome and seems to have known exactly what she wanted from the get-go, which is really impressive and commendable. I will say that I had like almost the exact opposite experience in life than she did. And so I maybe give you a little bit of a different perspective. I actually did not have any internships during college. I was in a little bit of a unique situation. We all know what happened 2 years ago. So that's definitely part of me and my story and how I got to where I am. And right now I have like, I don't want to like pat myself on the back too much, but I have an awesome job that I love. And I'm really proud of where I've gotten myself. I did not have an internship in school. I started as a biology major. So one thing that was really important for me, and if you know you want to be an engineer and you think that's what you want right now, definitely look for that ABET accreditation, look for the type of school that really, the more important thing that I would say is to look for a school that fits the type of person you are. I went to a small school where I just kind of did a blanket application, got in, I was like, great, I'm gonna be a biology major. Went, hated it, thought it was the worst thing ever. And so I was like, let me try biomedical engineering. And I did that for a little bit and I hated it. And then I ended up in the material science and engineering department, which I had never even heard of until I got to school. So for me, having that flexibility and the type of place where I could go and try different things and figure out what I really liked was really important to me. Because I hopped around so much, I did not have internships, but I found ways to make myself stand out and really sell myself on I worked in a lab during school that I loved and could talk really, talk about. And I had a fellowship through my school, so I could talk about that and how that got me really excited about being in the energy industry. So even if you find yourself on a non-traditional path, even if you find yourself in a place where you don't know exactly what you want right now, like, don't beat yourself up. People are going to make you feel like you need to join robotics team to be an engineer, and you don't. If you hate robotics team, don't do it. Don't make yourself do that. I did cross country, and that was just so much more fulfilling for me than when I tried to do robotics team. So really try to find things that you're passionate about and things that you could talk really excitedly about, and people will see that passion in you. Even if you go, I went to also a small school that people don't always know about, but the connections that I made in that school were awesome and got me where I am. So even if you feel like you're like, this school makes sense for me right now, but nobody's going to hear or know about it, doesn't really matter. Maybe your first job out of school, people are going to look at that job or that school title and think more closely about it, but also, it's not the end of the world. It's about the path as well as the destination.
Thank you so much for sharing that. I think it's great to hear the different perspectives, so.
Yeah.
Yeah, and thank you,
So
Kelly. I didn't mean to call you out.
No, that's okay. That's good. That's really good. I think we all have different experiences that led us to this engineering, so.
So along that same line of that question, because you two went to small colleges and I went to Ohio State, which is absolutely massive. I have a question, sort of. So at my college, we had lots of employers that would come to our college and interview students for internships and jobs, and there were always opportunities to interview through the College of Engineering because they would come to Ohio State. Did you have that kind of experience at a small college?
Absolutely. Yeah.
Yeah.
I mean,
Okay, good. So now we know.
the school I went to is a lot of people from Michigan go to Michigan Tech, and then they all go back to Metro Detroit and they work for employers down there. So that was considered a local feeder school, for those employers. What was nice about the small college is they had opportunities for us leading up to career fair to practice your resume, get help writing your resume, practice your interviewing skills. Even stuff as simple as, what do I wear? How do I look professional? Not too underdone, not too overdone, all that kind of stuff. There really are so many resources out there as a student that you just have to go and seek them out. And like Adana said, being your own advocate to figure those things out.
Okay. And then we had one more question. maybe I'll open up to Adana too. What's the benefit of getting a master's over a bachelor's degree in engineering? So I got a master's. Did either of, I don't remember.
I'm in a master's program right now, but it is not for engineering. It's for operations management. So that's more of a business / manager track.
So I got a master's in nuclear engineering, and I had originally gone and gotten a bachelor's in chemical engineering. I would say for me, the benefit was the school that I was at didn't offer the nuclear engineering as an undergrad. So I was able to take some of the nuclear engineering classes as an undergrad, but I really had to go to grad school to get the degree, the nuclear engineering degree that I wanted. It, in a way, it just allows you to get much deeper into a subject. It's not quite the level of a PhD, but say you do chemical engineering and then you go to grad school for a master's in chemical engineering. Perhaps you want some additional lab experience, or you just want to be deeper into a certain vein of chemical engineering, for instance, like semiconductors or something, and you want to do some work in that vein to make yourself a specialist in a certain subject. So that might be a reason that you do a master's over a bachelor's. I'd say you can get great opportunities with just a bachelor's. So I'd say it's the personal interest, and maybe you wanted to go into a field where you don't have quite the specialty you want yet, so you want to do a master's. And there's always schools will get you to do a master's because they want you to do a PhD, of course. And so getting a PhD really opens a lot of doors that, especially to academia, that you wouldn't have otherwise. I don't know if there's any.
Yeah, I guess I could add, so I don't think there's a need to rush into a master's initially. So I think it's perfectly fine to start off with a bachelor's degree and then start to get some work experience. Westinghouse, for example, will pay for folks to go back to school and get your master's program, as Kellyanne is living and breathing that right now. And it doesn't mean it's an engineering master's degree. It can be project management. It could be management, an MBA. So it's one of those things that make it the right timing for yourself. And so some schools will offer, hey, if you stay on for an extra year, you can get a master's degree, and maybe that fits for you. Maybe you want to go and get some work experience and then decide if you really want to go back to school. Or you can decide that I absolutely am perfectly fine with a bachelor's degree in engineering and not need to go to any other level. So all aspects are okay. It's really, again, that personal touch of what you want. And just because you don't know today doesn't mean you won't know in 5 years, 10 years. You can always make that decision. You can always go back to school. There's no time limit on there. I have colleagues that have started, before kids, after kids, it doesn't matter. There's colleagues that are starting it and, they're towards the end of their career, but they're like, this is a bucket list I want to do. And so they're doing it. So it's not a requirement, but it's just something where you need to figure out the right timing.
I would like to add that one of the reasons we probably all picked engineering, and one of the reasons that we're promoting engineering to you, is that unlike some of the straight sciences like chemistry or biology, you will find a very well-paying job right out of your undergraduate degree program. And that, for 4 years or 5 years, what you do to start off making that kind of money right away is awesome. And I think that's another reason to pick engineering, because yeah, you're delaying, as opposed to doing some sort of trade where you're doing welding or electrician work, you're delaying it a little bit with the cost of your engineering program, but you will set yourself up for the rest of your life. And the master's degree is just extra depending on what you want. So
Yeah, the bachelor's is really your foundation.
yes.
Always, if you're considering engineering, I would go straight into a bachelor's program for engineering. And then if you want to be a specialist, do the master's. It's going to teach you kind of how to think like an engineer. And even if you decide, oh, I really want to be a chemist, you're going to have those problem solving skills that will serve you in every other aspect of your life. So definitely, if you're like just even considering engineering, start doing some classes and see if you like it.
All right. So we are at the end of our time. I would really want to thank Hayley and Kellyanne and Adana for coming and helping me put this on. And thank you to everyone who logged in and brought students. We really appreciate you supporting us. And anything that we can do to support you, just let me know. I put my email in the chat. So if you have any follow-on questions, feel free to contact me. Thank you, everyone.
Yeah.
Thank you. Have
Thanks,
a great day.
everybody.